The question we are solving now belongs to test series 3. It is of network theory subject. In specific, it belongs to transient response analysis of RLC circuits. As per the circuit, there is a RLC circuit which is as shown in the figure. The circuit has an excitation of 60 volts. It has a 2 ohm resistance which is connected in series with branches as shown. The branches contain two 1 ohm resistors which are connected by a switch S, and the switch S is closed at t equal to 0. There are one inductor of inductance 1 Henry and one capacitor of capacitance 1 Farad. As per the problem, we need to find the current through the capacitor, that is IC of t at t equal to 0 plus. So from the given data we can see that the switch S is closed at t equal to 0. For finding the IC of t at t equal to 0 plus, let us analyze the circuit first at t equal to 0 minus. At t equal to 0 minus, the circuit would have reached the steady state, so the equivalent circuit can be drawn as shown. Please note that for this case, the switch is kept open because the switch is not yet closed at t equal to 0 minus. As the circuit would have reached the steady state, inductor acts as short and capacitor acts as open. So from this we can say that the current IL of t at t equal to 0 minus can be written as IL of 0 minus is equal to 60 divided by 3, that is equal to 20 ampere. This is due to the reason that there is no current flowing through this 1 ohm resistor because the capacitor is open. Similarly, we can say that Vc of 0 minus is equal to the drop across the 1 ohm resistor marked, which can be obtained by the voltage divider rule or Ohm's law as 60 multiplied by 1 divided by 3, that is equal to 20 volts. So by analyzing the circuit at t equal to 0 minus, we see that IL of 0 minus is 20 ampere and Vc of 0 minus is 20 volts. Now it is given that the switch is closed at t equal to 0 plus. So now the equivalent circuit can be drawn as shown. Please note that in this case the switch S needs to be closed because it is given that the switch is closed at t equal to 0 minus. Also note that at t equal to 0 plus, the inductor current can be given as 20 ampere and the capacitor voltage can be given as 20 volts. Now we know that we need to find IC of 0 plus. As the supply voltage is 20 volts and the resistors are of resistance 2 ohm, 1 ohm and 1 ohm, we see that from the given circuit, the source current can be written as IS of 0 plus is equal to 60 minus 20 divided by 2.5. This is due to the reason that the drop across the resistors can be given as 60 minus 20 and the equivalent resistance can be written as 2.5. This is equal to 40 divided by 2.5, that is equal to 16 ampere. Now by applying KCL at the node marked, that is 1, we see that IS of 0 plus is equal to IL of 0 plus plus IC of 0 plus. We know that IS of 0 plus is 16 ampere. We also know that IS of 0 plus is 16 ampere. We also know that IL of 0 plus is 20 ampere, as inductor does not allow abrupt change in current. So from this we can say that IC of 0 plus is equal to IS of 0 plus, that is 16 ampere, minus IL of 0 plus, that is 20 ampere. So which upon simplification becomes minus 4 ampere. From this we can see that the current through the capacitor at t equal to 0 plus, that is IC of 0 plus, can be obtained as minus 4 ampere using the properties of the inductor and capacitor during the transient nature. Hence the correct option is C.